The topic here is limits at infinity. So let's do example 2, this time algebraically. We just did example 1 and 2. We did them numerically. Let's try to do them using the theorem, meaning algebraically. The theorem says if r is positive and is a rational number, then a limit over 1 over x to the r as x goes to infinity is equal 0, as long as r is a positive number. So now, to do example 2, we know that we can rewrite this as a 1 here, right? When there's a nothing in there, that means the exponent is 1. So this should be equal to 0. Why? Because r is equal 1, which is strictly bigger than 0. Now same thing here. 1 over x means 1 over x to the exponent 1. So this has to be equal 0. Why? Because r is equal 1, which is strictly bigger than 0. We're still using the same theorem. Again, example 4, we're going to use the same theorem. This has to be 0. It doesn't matter whether x goes to negative infinity or a positive infinity. So y is equal 0 because r is equal 4, strictly bigger than 0. For example 5, we need to do a modification first. So we need to rewrite 1 over square root of x. We know that square root of x is x to 1/2. Now this is also 0 limits as x approach infinity. Now we know this is 0. Why? Because r is equal 1/2, which is strictly bigger than 0. It's a rational number that's bigger than 0. Same thing here. We need, for example 6, we need to rewrite our function. Our function's cube root of x squared is the same thing as x to the 2/3. Now x approach infinity, this has to be 0. Why? Because r is equal 2 over 3, which is strictly bigger than 0. It's 0 point something. Now, for example 7 and 8, I want to do this. First, I'm going to rewrite, because we have the 4, not a 1. To use that theorem, this is what we do. I would say this is the same thing as the limit of 4 times 1 over x as x approach infinity. Now we know, so we have to think of this as two functions. We know that 1 over x approach 0 using the theorem. So we could say this is the same thing as 4 limit of 1 over x as x approach infinity, which is 4 times 0, which is 0. So since it's a constant, you can take it outside. Now same thing here, this is the same thing as the limit of negative 7 times 1 over x to 1/3 as x approach negative infinity, which is equal minus 7 limit of 1 over x 1/3 as x approach negative infinity. This is equal negative 7 times 0, which is 0. Why? Because r is equal 1/3, which is strictly bigger than 0. And that's it for these examples.